All right, how's it going out there in remote land? We are back studying about sedimentary rocks, right? We left off talking about igneous rocks, and then we jumped into a little rock cycle. Well, today we're going to chat about the formation of sedimentary rocks and where that fits into the whole scheme of things. Here you can see some beautiful sandstone formations out in a desert-like environment. There's that red color, which, if you remember from igneous rocks and minerals, oftentimes indicates the presence of iron, right? That rusting gives you that gorgeous red look. It's not so pretty on the chain of your bicycle when you leave it outside, but in a rock it's very pretty. And here we have some underground formation, right? Some chemical dissolving going on of limestone. Limestone is a sedimentary rock as well as the sandstone from here. So really pretty rocks. They are soft rocks, and their formation is much more gentle than the Born of Fire igneous, and they're really cool. So let's do it. I'm going to start out with a little clip from a classic old movie. I'm sure you'll recognize it. Here we go.
100 million years ago, there were mosquitoes, just like today. And just like today, they fed on the blood of animals, even dinosaurs. Sometimes, after biting a dinosaur, the mosquito would land on the branch of a tree and get stuck in the sap. After a long time, the tree sap would get hard and become fossilized, just like a dinosaur bone, preserving the mosquito inside. This fossilized tree sap, which we call amber, waited for millions of years with the mosquito inside, until Jurassic Park scientists came along.
All right, so pretty cool stuff. Sedimentary rocks have the ability to house fossils, right? They form gently. There's no melting involved like with igneous. They call it a lithification, and the tree sap is one way to preserve, life. Burial, as you saw in that second part of the clip there, another way to preserve it, and it protects it from weathering and erosion and ultraviolet energy and all sorts of breakdown. So the fossils get preserved in sedimentary rock. Read this through. Interesting little clip there. Watch carefully on the top right. Over time, sediment gets washed down. Here's a river. And the sediment is coming from higher up. And it gets taken to the lowest point by gravity. And it piles up, right? It builds up, stacks up. It gets buried. And on the bottom, you get more and more pressure. Right? I'm sure you've been in a human pileup where the person on the bottom starts to get crushed and is screaming. Well, that's what's going on here. These layers are pushing down, compacting, and ultimately you're going to make sedimentary rock, right? It'll form into a sedimentary rock there. Okay? Okay. And there you have it. Over time, you'll get uplift, right? So what was once below the ocean gets uplifted by plate tectonic forces. We'll talk all about that. And now these layers are exposed at the surface, and they used to be under the water. So you can often find marine fossils on land, right? Because that land has now been uplifted. So pretty cool stuff, okay? How are land-derived sedimentary rocks formed? Well, check it out, okay? First, you have the process of weathering, okay? And weathering is that breakdown into smaller pieces. We call that sediment. Then they get carried someplace, either blown by the wind, transported by water, gravity. That's called erosion. And then ultimately they get deposited, usually in a place that's lower, right? Gravity pulls things downhill. And then you get that buildup like we saw in that simulation before. Compaction occurs, right? You get that squeezing, the water gets squeezed out. You'll get cementation occurring. And ultimately you form a sedimentary rock. And you can see it in the cycle up here. Compaction and cementation. You get deposited and buried first. And you can see how it all fits into the cycle there. Okay? These two words together, sometimes they'll use the generic word lithification. That's the process of making a sedimentary rock. For igneous rocks, it was either solidification or crystallization, right, from that cooling of magma. But for sedimentary, we use the word lithification, which means to make solid. Okay? This was an interesting article. A lot of people didn't realize they had primitive submarines back during the Civil War time. And this one in particular ended up getting sunk. You have to read the story here. And over time, silt came into the boat, and the sailors weren't able to escape. So they were buried in these layers of silt and became, human fossils, if you will. And they finally found the boat a few years back, and they brought it up, and they wanted to respect the human remains, of course. But there were some human remains that were fossilized through that process of lithification. Now, it didn't become a full solid because it wasn't buried that deep, and it still stayed moist, but it preserved the remains, and that's, of course, what sedimentary rocks do. They preserve those remains. Okay. How else can sedimentary rocks form? Well, when water evaporates, the mineral precipitates, and that can leave, like, for example, if you ever have a dripping faucet, you'll see that stain start to form in the sink, the kind of a red or a green stain. Well, as the water's evaporating, those minerals are precipitating and sticking to your sink. All right, sometimes they call them lime deposits. Another way, of course, plants and animals, when they die, they get buried, and you get this organic remains of concentrated carbon, and you might make coal. So a lot of different types of sedimentary rocks, really cool stuff. Right, that's showing you a dissolved mineral there, right? Those are those caves underground, mostly a limestone. Over here showing you shells, right? When shells get cemented together naturally by Mother Nature, they also call it a sedimentary rock, and they give it a cute name, coquina. Might be a cute name for, they have a kid someday. Anyways, how are sedimentary rocks formed chemically or organically? Well, there it is. They're called crystalline. The water evaporates, the mineral precipitates, and you get this crystalline structure there. Okay. Also, if there are shells in the area, they will be cemented together as well. If that happens, that's called an organic process there. Bioclastic is the name of that texture. You can see living things biology. Clastic means pieces. So once living things cemented together, they call that bioclastic. Right, and there's your coquina, which is a type of limestone as well. Okay. Here's the chart in your reference tables. It's pretty well organized. Up top, all of these rocks form from compaction and or cementation of mostly land-derived sediments. And you can see that there. As you go down the chart, the sediments get smaller and smaller, and their sizes are here. Okay. Below that part here, you can see these are chemically or organically formed. Usually a marine environment forms these as opposed to land-derived sediments. A lot of these will form from the result of the evaporation of water, like we were saying. All of these minerals can be dissolved in water, and when the water evaporates, they start to crystallize. So you'll get your rock salt, rock gypsum, dolostone, limestone. Those are all formed in a marine environment. The one on the bottom here, bioclastic, we talked about coal, or if you have shells cemented together. Well, that's where these two are going to be found on the chart, and they call those bioclastic textures there. Okay. Now this is soft coal. This isn't the type of coal that you would see them throwing in the locomotives. That was a metamorphic coal, a lot harder, burned a lot hotter. We'll talk about that. But this is a softer version of coal. Okay. If you could hit pause in a second, I'd like you just to jot down a word or two of things that you see in the rock that would make it sedimentary. What characteristic do you see in these rocks? Just jot it down under the picture there, and then we'll go through that. So hit pause, take a minute. Okay, so just in general, I'm sure you had many things written down, but for the first one there, the thing that should jump out at you, it's got lots of layers, right? If you see layers in a rock stacked on top like pancakes, you're looking at a sedimentary rock that was formed over, thousands to millions of years as sediments became deposited. So layering is a characteristic of sedimentary rock. The next one here, you can see pieces of other rock. Okay, we call those fragments. And if you see pieces of other rock cemented together, That's also a classic sedimentary characteristic. For the third one there, I'm not sure what you wrote down there. We'll chat about that in a minute, but these are mud cracks. And if you do see that, you're talking mud is made from small sediments, silt and clay. And when it gets squeezed and then the water evaporates, you get these this mud cracking situation, and that is all sedimentary, of loose land-derived sediment. The fourth one, I know that's pretty tough to tell, but believe it or not, those are raindrop impressions. If you were playing with clay and you left the clay outside and it started to pour, it would get these little divots from the hard rain hitting in soft clay, and then the clay would eventually harden in the sun, and you would get these raindrop impressions. Well, that too was once soft land-derived material, so sedimentary. And of course, the last two, these are pretty obvious there, right? Those are fossils. And if you have a fossil in a rock, it is sedimentary with very few exceptions. Sometimes in a gently metamorphosed rock, you can get a fossil that's all distorted and screwed up, but that's the exception to the rule. They're mostly found in sedimentary rock, and they're usually perfectly preserved. So very, very neat stuff. Okay? Okay. So for your summary, a couple questions for you here, and of course some readers' questions after that. Put some love into it. We'll go through it back in the meet. See you there.